Hey guys, this is Mrs. Gephardt. I'm just here to give you the notes on the rock cycle. So we'll get started. As we start with every other type of notes, we have some essential questions. So these are the things you need to be making sure that you can answer when you are finished with this. First off, what is the rock cycle and how does it work? And then the second piece is, how do these rocks change from one type to another? So to begin with, we do have some just terminology that we need to make sure we understand before we even get into the rock cycle. The first vocab word or first piece of terminology that we have is the word weathering. Second we have is erosion. Third is deposition. Fourth is cementation. And fifth is compaction. And as we can see, here's a diagram of the rock cycle and, of course, the rock. So the very first term we're going to talk about is weathering. And weathering is any kind of, it could be chemical or it could be mechanical process that breaks rock down. And this could be being exposed to the weather, like rain or winds. It could be not just the rain, but what's in the water. So for example, we know that with pollutants that get into the air, we get things and we produce something called acid rain. And this acid rain can eat away at rock. That's also a weathering that can occur. So that's more of our chemical. But as we can see with this rock layer, we're missing pieces in here. We've got gaps in here. Obviously, this piece of rock was not made in this shape. It was probably in some kind of square or rectangular shape. Erosion is our second term, and it goes really well with weathering. So the weathering, it breaks it down. With the erosion, what happens is it's moving it. It's transporting it to a different place. So it could be, if we look at this as the Grand Canyon, okay, all of this rock has been broken down over time because there's a lot of rock missing. And here we have this river sort of running through it, and this river can carry all of this rock or sediment down to another place to be deposited. But wind, again, sorry about the ads. It could be wind, light, gravel, or dust, or whatever could be blown around in all different directions, or just the power of water could erode the soil or rock away and be transporting it so it can be deposited in another place. So now I think of deposit. So we have a weathering and an eroding, and it moves it down, and then we put it somewhere else. And oftentimes you will see this type of event occur. Maybe you're more familiar with it if you've been to the beach, or you've seen beach renourishments or whatever. This river that I've kind of made this arrow on is moving in that direction of the arrow, and it's carrying lots of sediment. And as we can see, this sediment can start depositing itself. So what we could expect to see, let's say we come visit this river 100 years from now, this whole area could be completely restructured because of the way that the sand and sediment is being deposited. We could completely change the flow of this river out into this major waterway. Now with compaction, what this means is that, and we can see it right here, the rocks are sort of put very closely together. We can see some gaps in here, but it's like it's squeezed together. We've pinched it and we've put it as close together as we can. We have some, there's always going to be some spaces, but it's put closely and packed tightly together. And then from cementation, what happens is we think of that those rocks that have all these, it's packed together, but there's some spaces. Well, all of these spaces are filled with water and minerals, and literally it hardens and acts like a glue. So when you see rocks out anywhere and they look like just this big old mess of different types of rock kind of all stuck together, that's literally what it is. It's been cemented together. And that's kind of what you see here, where it's just a whole bunch of different stuff. All the empty space was filled with this mineral in this water and literally glued it all together. So now I want you to flip it over to your rock cycle sort of concept map that we have going on here. And we're starting up at the very top, as you can see, with the sedimentary rock. And so some just details about sedimentary rock, and yes, you should be filling this in. Sedimentary rock tends to be very thick in layers. We can imagine things like the Grand Canyon or whatever, very nice pretty layers that are like this, but they can be very thick. It's loosely compacted because sedimentary rock, let's look at this. It's made up of sediment. And sediment is things that is blown around or moved through water processes, things like that. Distinct particles means that we can look and see, as we look at the rock, we can see distinct pieces to it. And dull in appearance just simply means it's not something very shiny and pretty. This is, if we look at this sandstone, it's very dull looking. And in order to get this process, and on your sheet you've got an arrow, so I'm kind of drawing that arrow in. But in order to get this process, or these sedimentary rocks to form, it undergoes weathering, erosion, deposition, cementation, or compaction. A combination of them, it could be one of them, but that's how we get the formation of sedimentary rock. Alright, so now we are heading down to the right. So if you imagine the sedimentary rock on your note sheet is up here, the little box that we just filled in, and now we're heading, and here's our, pretend there's the box, we're heading in that area and filling in those boxes towards this igneous rock. So if we wanted to go from igneous rock to sedimentary rock, this is what we're going to have to undergo. This is what that igneous rock is going to have to undergo. It's going to have to be weathered, eroded, deposited, cemented, or compacted. Combination of them all as well. If we're trying to move from sedimentary rock to the igneous, we have a melting and cooling event. And I do have a reason for these crayons, because we can imagine a crayon melts and then it cools and it hardens. And that's exactly what happens when we go from sedimentary rock to the igneous rock. So now we're down at the bottom right, and we're at the igneous rock formation. And I'm going to draw in that arrow that is not present. Sorry about that. But we're right here. We're focused on igneous rock. And igneous rock, the way the rock forms is very dependent on how fast or slow it cools. So if we have a rock that cools very, very quickly, it's going to be very glassy in appearance, but it's going to have holes. If it cools just fast, so not very fast, just fast, it's going to be glassy. And we can see that with this obsidian. You can very much tell, even right in here, it's got a very glassy appearance to it. If it cools slow or very slow, we're going to see crystal formation. And we can see this crystal formation in something like granite. So you can kind of see all these different areas of crystal deposit within this granite rock. And in order to get the formation of this granite rock, we've got this melting and cooling that will occur. And this igneous rock it's going to be coming from the magma of the earth. And so that magma is going to hit a certain point. It's melted, and then it's going to cool, just like the crayon example that I just said in the previous slide. Okay, so now we are, this was the igneous rock, and we're moving to the side. So if you look at your note sheet, you're kind of center of the note sheet, but towards the bottom a little bit. And we can see the arrows. So if we wanted to move from igneous rock onto metamorphic rock, we would have to undergo some heat and pressure. So here's our example of heat. Little fire there. And pressure, and what this is showing you is actually, if you did not know this, diamonds are just simply carbon that has been compressed, that has been put under extreme amounts of pressure. That's how it's formed. So I found a picture, thought it would be kind of cute to do. If we were coming from metamorphic rock, which would be coming from this direction, we would undergo a melting and cooling event. So obviously we have our little ice cream cones that are melting, and then we've got ice, just kind of telling us melting, cooling events that can occur. Alright, so then we now have reached our metamorphic rock. That's over to the far left, and I know in your sheet you've got an arrow. Metamorphic rocks, they're thick layered, they're very tightly compacted, they're blurred particles. If you kind of look in here, you can tell it's kind of blurry. It's not something very distinct. It's kind of like it's a blurred paint job almost. And then it's got a shiny appearance. And this doesn't seem as shiny, but this is an example of marble. So if you've ever seen marble, if you've been in a nice building that's had marble, or maybe your house has marble in it, it's a very shiny surface. And in order to make this metamorphic rock, it has undergone some kind of heat and pressure event. So a tremendous amount of heat and some kind of pressure, probably pushing in on the sides, as I see my little arrows pushing in, really even to the top and bottom, kind of squishing it together. And now we're heading from that metamorphic rock, and we're heading all the way back up, and that's coming back up to that sedimentary rock box that's up at the top. So that's kind of the point in the chart that we are at. And in order to go from this metamorphic rock up to that sedimentary rock, that metamorphic rock is going to have to be weathered, eroded, deposited, cemented, compacted. And if we were going from the sedimentary rock to the metamorphic, it would be undergoing a tremendous amount of heat and pressure. And over here, this is just some weathering and erosion events that have occurred with this particular rock. So now we're at the very bottom of the sheet, and at the very bottom of the sheet you should see this nice little smaller box. But the first piece, it says the rock cycle, and the rock cycle, that's the definition right here, the continuous changing of a rock from one type to another. It's a cycle, so we have to imagine a cycle is cyclical. It means it's a circle. So there's no real beginning or end to it. We're just constantly going to be moving around it, and then we could be going in this direction or whatever, but it's a cycle. It's constantly, we're moving from one to another. The second line, and that's going to be focused here, all rocks can turn into all types of rocks. So for example, sedimentary rock can turn into sedimentary rock, metamorphic, igneous. Igneous can turn into sedimentary. Metamorphic can turn into sedimentary. Sedimentary can turn into igneous. Igneous can turn into metamorphic. It's a cycle. So we have to think back here to this cycle. It's constantly, there's movement in a cycle. So now we've hit the end. We've come back and hit our essential questions. So you should first be able to answer, explain what the rock cycle is and how it works. Okay. And the second question is then, how do rocks change from one type to another? I hope this has helped you understand the rock cycle better. And if these questions are not something that you can easily understand, please go back and review this video. Remember, as many times as you need to, pause, rewind, fast forward, however you need to do it. And if you still have questions, please see your teacher.